Hello, I'm Brian Watrous of VMware Education. In this segment, we're going to discuss how to use thin provisioned virtual disks. As you can see illustrated in this slide, it's entirely possible to have multiple virtual machines all on the same host, each accessing their own virtual disks. The virtual machine that you see on the left is using a traditional style virtual disk. Traditionally, virtual disks are thick provisioned. Thick provisioned virtual disks have all of their data blocks pre-allocated when you create the virtual disk. So in the case of the VM on the left, its virtual disk is 20 gigabytes, and we've allocated all 20 gigabytes, once again because it's a thick provisioned disk. The virtual machine in the middle has a thin provisioned virtual disk. When you create a virtual disk, you have the option to create the disk as a thin provisioned disk, which we've done in this case. We're creating a disk that appears to be 40 gigabytes, but notice in this diagram that the actual amount of data blocks that we've allocated thus far is only 20 gigabytes. With the thin provisioned virtual disk, we delay the actual allocation of data blocks until the point in time when it's actually necessary to have those data blocks. In other words, we dynamically allocate data blocks on the fly. The VM on the right also has a thin provisioned virtual disk. You'll notice that we're creating a virtual disk in this case which appears to be 80 gigabytes, but thus far we've only allocated 40 gigabytes. Now with thin provisioning, one of the main benefits of thin provisioning is we're able to defer the purchase of the actual disk space that we need until a later point in time. If we can defer the purchase of our storage space, the same dollars that we have to spend on storage today is going to go farther and allow us to purchase more storage in the future. So by deferring the purchase of the storage, we're able to give the virtual machines the appearance that they have their full allocation of storage space, but allocate that space on the fly later on. Continue with this particular example, you'll notice that we have a 20 gigabyte thick disk, a 40 gigabyte thin disk, and another 80 gigabyte thin disk for a total of 140 gigabytes. Now, though it may seem impossible, we can actually store all three of those virtual disks in the data store illustrated on the bottom of the slide. That data store only has a 100 gigabyte LUN, in which there's 100 gigabyte VMFS. And you would think perhaps that 140 gigabytes of virtual disks wouldn't fit in that 100 gigabyte LUN. But in fact, with thin provisioned virtual disks, we can. If you do a little quick arithmetic here, the first disk has 20 gigabytes allocated to it. The second disk, though it appears to be 40 gigabytes, only has 20 gigabytes. So far we have 40 gigabytes total. Then that third virtual disk, which is also thin provisioned, is only using an additional 40 gigabytes. So if you add the actual amounts of storage that we've allocated thus far, 20 gigabytes plus 20 gigabytes plus 40 gigabytes, that's only 80 gigabytes. And 80 gigabytes of disk space will fit within a 100 gigabyte VMFS data store. Now, that technique of creating thin provisioned virtual disks and storing thin provisioned virtual disks that appear to consume more disk space than you actually have is a technique called overcommitting data stores. Now, from the sounds of it, overcommitting a data store may not sound like a wise thing to do, but again, if we overcommit data stores, we can defer the purchase of the disk space to a later point in time when our dollars will purchase more. If you overcommit your data stores carefully, using the techniques that we'll discuss here in a few moments, you can safely overcommit data stores, but part of the burden of doing so falls on our shoulders, and part of the burden of doing so correctly falls on your shoulders. On our shoulders, we take upon the task of making certain that we actively monitor your data store capacity. We have two alarms that monitor to detect, in the case of the first alarm, the moment you overcommit a data store, we will let you know through an alarm. But additionally, once a data store has been overcommitted, or even if you aren't overcommitting data stores, we have another alarm which will keep you posted in terms of how much storage space a particular data store is using. By default, that alarm will trigger a yellow warning when you exceed 75% disk utilization, and you'll trigger a red alert if you exceed 85% disk utilization. So through the combination of those two alarms, plus the reporting that we provide, we VMware make you aware of your actual activities when it comes to thin provisioning and in particular overcommitting your data stores. But from that point onwards, it's up to you to make certain that you increase the size of the data store, if necessary, to provide the disk space that we actually need. So in the example of the previous slide, we saw that we currently had 80 gigabytes of disk space being used in a 100 gigabyte VMFS. At that point in time, we have enough disk space, but as the actual storage utilization level increases in that data store, as we go from 80% to 85%, 90, 95%, you're going to want to pay attention to that second alarm to make certain that you know in advance to add the disk storage space that you need to make certain that you have the space that you need when you need it. Alternatively, instead of adding disk space to a data store, you can leverage technologies such as VMware vSphere, vStorage, vMotion to migrate virtual machines out of a data store that's filling up into a data store that still has space. That way you can balance the storage needs across data stores to provide the space that we need. In the following demonstration, I will show you how to create thin provision disks. In this demonstration, I will show you how to create a thin provision virtual disk. To do so, I'm going to first go to VMs and Templates view. I'll then select the virtual machine that I want to give the virtual disk to. I'll right-click the virtual machine, then choose Edit Settings. And in the Edit Settings wizard, we can see the hardware that this virtual machine already has. Notice that it currently has two virtual disks. One's called hard disk 1. The other disk is called hard disk 2. I'm going to add a third disk. When I click Add, I'm asked what type of hardware I want to add. I'm going to specify I would like to add a virtual hard disk. And on the following screen, I'm asked whether I want to create a new virtual disk, use an existing virtual disk from another virtual machine, or to use a raw device mapping. I'm going to choose to create a brand new virtual disk. And on the following screen, the first thing I'm asked for is what size virtual disk I'd like to create. Now, since I am creating a thin provision virtual hard disk here, I have a bit of flexibility. In the data store I'm about to use, there's only 5 gigabytes of storage space left available. But notice, because I'm creating a thin provision virtual hard disk, I can create a virtual hard disk that's even larger than the amount of space that's in that data store. So to illustrate that point, even though there's only 5 gigabytes of storage space left, I'm going to choose 6 gigabytes. Now, as I described earlier, I can create a virtual disk that's thick provisioned or thin provisioned. I'm going to choose a thin provisioned virtual disk in this case, and I will specify specifically which data store I want this thin provision virtual hard disk to reside in. As I did before in a previous segment, I will once again choose the My Data Store data store, and when I click OK, followed by Next, you'll notice that it tells us here that the disk capacity specified is greater than the amount that's available in the data store. It goes on to say that disk space overcommitment can lead to filling up the virtual disk and blocking the virtual machine. So it's giving us a warning right from the start that we're venturing into the territory of overcommitting your data store. And again, if you do so wisely, you can proceed safely. On this screen, I'm provided the opportunity to present the virtual disk in a variety of different ways. I'll simply go with the defaults for now. And on the following screen, we have a summary that points out what we're about to do. We're about to create a 6 gigabyte thin provisioned virtual disk in the My Data Store data store. If I click Finish, followed by OK, you'll notice in the recent task that it tells us that we are creating a new virtual hard disk. And indeed, it has completed the task. If we then go edit the settings for the virtual machine, as you can see in the Edit Settings wizard, this virtual machine now has 3 virtual hard disks. If I select the virtual hard disk that we just created, hard disk 3, you can see on the right side of the interface that this virtual disk is thin provisioned. The previous virtual disk that we created in an earlier segment, the one called hard disk 2, is a thick provisioned hard disk. So in this demonstration, we've seen how to create a thin provisioned virtual hard disk, and furthermore, once you start creating virtual disks of different types, how to determine whether a virtual disk is thin provisioned or thick provisioned. This completes this demonstration. VMware Education Services offers training in over 500 training centers across the world in 60 different countries. We offer both direct training and training through our VMware authorized training centers. We offer instructor-led training in both classroom and live online formats. We offer private on-sites and e-learning modules available online. To find out more information, please see us online at the URLs listed on the screen. Thank you.